Good morning, my dear students. So here today I have brought chapter 9, Force and Laws of Motion. It is a very interesting chapter for the one who are interested for the physics. So this is class 9 science part 1 introductory video on chapter 9, Force and Laws of Motion. So let's begin. This in the picture. He is Sir Isaac Newton. Newton built on the work of scientists such as Galileo, published his work after many years in the book entitled Principia. He first had to define force and the mass. He then defined his laws of motion. Newton's first law of motion. Newton's first law of motion states that the motion of an object does not change as long as the net force acting on the object is zero. Thus, unless an unbalanced force acts, an object at rest remains at the rest, and the object in the motion remains in the motion with the same speed and the direction. That means unless you move certain object or you break certain speed, that object will keep on moving or it will be at the rest position. Newton's first law of motion, often called the law of inertia. Inertia is the tendency of the object to resist a change in its motion. First law of motion. Example. Think about being a moving car that is involved in the front end collision. The collision makes the car stop suddenly, but what happens to you as the passenger? Because you had inertia, you continue to move forward. So even if you had applied brake, your upper body is going in the backside because of the inertia that had the motion in your body, because you were going ahead. So you will just go aage and then you will stop and you will go back. Laws of inertia. Crash test. What force acts on the crash test dummy to slow its forward motion? Seat belt. The seat belt tightens immediately to slow down the dummy and absorb energy. Inflating airbags. The bag exerts a force that slows down the dummy forward motion, absorbing its energy and prevent it from hitting the steering wheel. So that is the principle on which your airbags which are there in the car work. Newton's second law of motion. An unbalanced force acting on the object affects the motion of the object by causing the object's velocity to change. The object accelerates. Newton's second law explains what happens to the object when unbalanced force acts on it. Suppose you are drawing a ball or an object from upside from the third floor or fifth floor. That ball will accelerate and try to move downwards due to gravity. It describes the relationship of force acting on the object to the acceleration of the object. Force versus acceleration. When you throw a ball, you apply a net force to it. Harder you throw it, more it accelerates. Acceleration of ball is directly proportional to the net force acting on it. If you double the force acting on the ball, acceleration of ball will double. Therefore, force increase when acceleration increase. I can say that both are directly proportional with each other. Mass versus acceleration. Newton also learned that the acceleration of an object depends on the mass of the object. Increase in mass will increase in acceleration. So mass is a measure of inertia of an object, depends on the amount of matter and the object contained. For example, compare hitting a tennis ball then a basketball with the same force using a tennis racket. So you know that tennis ball and the basketball both have the different mass. More the mass, more the force is required. As mass increase, acceleration decreases. They are inversely proportional to each other. Newton's second law summarizes in a mathematical equation the relationship of force, mass and acceleration. Acceleration is equal to net force acting on the object divided by the object's mass. Acceleration is net force upon mass, which is A is equals to F upon M. Can be written solving for the force. Force is equals to ma. F is equals to ma. Here M is mass and A is acceleration. Explore Newton's third law through the lens of an amusement park. Newton's third law of motion. You must have used this right some on the other day during your park visit. Bumper cars illustrate Newton's third law. The goal is to slam into the another car head on so that it jolts the other driver. There are two parts to this collision, however, because the collision causes your car to rebound sharply as well. So that's why there are the cushions in the base place. They will absorb all the shock so you don't get hurt. Newton's third law of motion. A force cannot exist alone. Force exists in the pairs. According to Newton's third law, whenever one object exerts a force on the second object exerts an equal and opposite force on the first object. Just example, you are hitting a ball on the wall with the same force with the opposite direction that ball is coming back to you. That's the Newton's third law. These two forces are called the action and reaction forces. Newton's third law of motion. The force your bumper car exerts on the other car is the action force. The force the other car exerts on your car is the reaction force. These two forces are equal in size and opposite in direction, and that is why none of you get hurt. Newton's third law, summarization. Not all action and reaction forces cause motion. You may be wondering why the action-reaction force do not cancel and produce a net force 0. The reason is that the action-reaction forces do not act on the same object. Only when the equal and opposite force act on the same object do they result in the net force of 0. Example, a swimmer uses her arms to push against the water, creating an action force. The action force causes water to move in the direction of action force. Water exerts an equal and opposite reaction force on the swimmer, pushing her forward through the water. They do not cancel each other because action force act on the water, reaction force act on the swimmer. So here object changes, so they do not cancel each other effect. First scenario for action-reaction forces in a pair. A rocket moves in the outer space with the gas propelled out the back. Action forces, gas particles are thrust out back of the rocket. Reaction, the gas applies a force on the rocket. Scenario 2. A person jump out of boat. Action forces foot pushing off the boat. The reaction forces the boat pushing on the person's foot. So here net result force is going to be 0. Action reaction force in a pair. Scenario 3. A player kicks a saucer ball. Action is foot puts force on the saucer ball. Reaction is the saucer ball exert a force on the foot. So in this all three scenarios, the net force is going to be 0 because action reaction force apply on the same object, vice versa. So this was all about the first introductory video on laws of motion. In the next coming videos, we will discuss more about this in detail. Bye bye. Take care.